Unveiling the mystery of time. Is it real? Does it flow? Imagine for a moment that you could press a magical pause button on life itself. In an instant, everything around you would freeze, the birds in mid-flight, the leaves swaying gently on the branches of a nearby tree. Even the very air molecules would hang motionless, suspended in a single moment of eternity. This fantastical scenario may seem like the stuff of science fiction, but it raises a profound question about the very nature of our existence. What exactly is time? Is time a river that flows steadily forward, carrying the universe and all within it on an inexorable journey through the moments of existence? Or is it something far more complex, a construct of our minds, a way of perceiving and organizing the ever-changing dance of events that unfold around us? For centuries, philosophers, scientists, and thinkers of all kinds have grappled with the enigma of time, probing its depths, challenging our assumptions, and offering tantalizing glimpses into the true nature of this most fundamental, yet elusive, aspect of our reality. In this exploration, we shall delve into the heart of this age-old debate, examining the philosophical and scientific perspectives that have shaped our understanding of time, and perhaps unveiling some of the mysteries that continue to perplex even the greatest minds. So, let us begin our journey, guided by the wisdom of the ages and the insatiable human thirst for knowledge and understanding. Together, we shall navigate the intricate pathways of reason, logic, and scientific inquiry, seeking to unravel the secrets of time itself, the puzzling nature of time. We all have an intuitive sense of time, a perception that it is an ever-present force, an invisible current that carries us through the moments of our lives. We measure it with clocks and calendars, dividing it into seconds, minutes, hours, days, and years. We speak of it in familiar phrases, such as time flies or time heals all wounds, as if it were a tangible entity, a river upon which the events of our existence unfold. But what exactly are we measuring when we speak of time? Are these units of measurement, seconds, minutes, hours, merely human inventions, convenient ways of organizing and quantifying the passage of events? Or do they represent fundamental properties of the universe itself, intrinsic qualities of the fabric of existence that transcend our subjective experiences? These questions lie at the heart of the enduring mystery of time, a puzzle that has confounded philosophers, scientists, and thinkers for millennia. Is time an objective reality, a fundamental dimension of the cosmos that exists independently of our perceptions and measurements? Or is it a subjective experience, a construct of our minds, a way of making sense of the ever-changing dance of events that unfold around us? This dichotomy between the objective and subjective nature of time has given rise to a rich tapestry of philosophical and scientific inquiries, each offering a unique perspective on this most enigmatic of concepts. Is time real? Different philosophical positions. Within the realm of philosophy, several distinct positions have emerged, each offering a different interpretation of the nature of time and its relationship to the fabric of existence. One perspective, known as presentism, argues that only the present moment is truly real. According to this view, the past and the future are mere abstractions, memories and expectations that exist only in our minds. The present, the fleeting instant we experience in each passing moment, is the only tangible reality, the only aspect of time that can be said to truly exist. Eternalism, on the other hand, takes a radically different stance. This theory posits that the entire timeline of existence, past, present, and future, is equally real and equally existent. Rather than a linear progression of moments, eternalism envisions time as a vast, four-dimensional landscape, akin to a film reel containing every frame, every moment that has ever been or will ever be. Closely related to eternalism is the concept of the block universe, a theory that emerged from Einstein's groundbreaking work on relativity. According to this view, time is inextricably woven into the fabric of space-time, a fourth dimension that exists alongside the three spatial dimensions we are familiar with. In this block universe, everything that has ever happened or will ever happen already exists, frozen in a vast, four-dimensional continuum. Each of these philosophical positions offers a unique and thought-provoking perspective on the nature of time, challenging our fundamental assumptions and inviting us to question the very foundations upon which our understanding of reality is built. Does time flow? The arrow of time, one of the most perplexing aspects of time, one that has confounded philosophers and scientists alike, is its apparent one-directional flow. Why does time seem to move only in a single direction, from past to future, and never in reverse? This enigmatic quality of time has been dubbed the arrow of time, a metaphorical representation of its seemingly inexorable forward momentum. But what is the underlying cause of this phenomenon? What force or principle governs the unidirectional flow of time, and why does it appear to be an inviolable law of nature? One potential explanation for the arrow of time lies in the concept of entropy, a fundamental principle of thermodynamics that describes the tendency of systems to move from order to disorder over time. As the universe evolves, entropy increases, leading to an overall increase in disorder and a diminishing capacity for useful work or energy to be extracted from a given system. This increase in entropy, some physicists argue, may be inextricably linked to the arrow of time, as it establishes a clear directionality to the evolution of the universe, from a highly ordered state in the distant past to a state of ever-increasing disorder in the future. In this sense, the flow of time and the increase in entropy may be two sides of the same coin, intrinsically connected phenomena that shape the very fabric of reality. However, our subjective experience of time's flow adds yet another layer of complexity to this enigma. Our brains, it seems, perceive time in a highly variable and malleable way, with our emotional states and experiences influencing our perception of its passage. Time might seem to slow down during moments of intense excitement or danger, while dragging interminably during periods of boredom or monotony. This psychological aspect of time's flow further complicates our understanding of the phenomenon, suggesting that our perception of time's arrow may be influenced by both objective, physical principles and subjective, neurological processes, a tantalizing interplay between the external reality of the cosmos and the internal workings of our minds. Theories on time travel and the implications. The enigma of time's nature and flow has also given rise to one of the most captivating and mind-bending concepts in theoretical physics and science fiction, the possibility of time travel. If we embrace the philosophical positions of eternalism or the block universe, which posit that the past, present, and future coexist simultaneously, it raises the tantalizing prospect of being able to move freely along the timeline of existence, to visit distant eras and witness events long since past or yet to come. However, the concept of time travel is not without its paradoxes and conundrums. The infamous grandfather paradox, for instance, raises the perplexing question of what would happen if a time traveler were to go back in time and inadvertently, or perhaps intentionally, alter the course of events in such a way that their own existence is prevented, for example, by killing their own grandfather before their parent was conceived. This paradox highlights the profound implications and potential logical inconsistencies that arise when we consider the possibility of altering the past, and it has sparked intense debates and hypothetical scenarios among philosophers, physicists, and science fiction writers alike. Despite these apparent paradoxes, the allure of time travel remains strong, and many theoretical physicists continue to explore the possibility within the frameworks of quantum mechanics, general relativity, and other cutting-edge theories. Some have even proposed theoretical models that might allow for a form of time travel, such as traversable wormholes or closed time-like curves, though the practical realization of such concepts remains firmly in the realm of speculation. Regardless of whether time travel is ever achieved, the mere contemplation of its possibility has helped to shed light on the profound mysteries and complexities inherent in our understanding of time, pushing the boundaries of our knowledge and challenging us to question the very foundations of our perceived reality. The search for a unified theory. In the realm of theoretical physics, the quest to unravel the mysteries of time is inextricably linked to the pursuit of a unified theory, a single, comprehensive model that can reconcile the seemingly irreconcilable, the subatomic realm of quantum mechanics and the cosmic realm of general relativity. While quantum mechanics governs the behavior of matter and energy at the smallest scales, general relativity describes the large-scale behavior of the cosmos itself. Yet the two theories appear to be fundamentally incompatible, with quantum mechanics treating time as an illusion, while general relativity embraces time as a fundamental part of the fabric of reality. Physicists have long dreamed of a theory that can bridge this apparent paradox, a model that successfully unites quantum mechanics with general relativity and provides a framework for understanding all forces of nature, from the strong nuclear force to gravity itself. Some have postulated that the answer to this conundrum may lie in the realm of the Planck scale, the infinitesimally small scale at which the forces of nature were originally unified in the incredible energies of the Big Bang itself. At this scale, the strange phenomena predicted by quantum mechanics are believed to be so intense that the normal laws of physics break down completely, making it incredibly difficult to observe or measure events in a conventional manner. And it is at the Planck scale where the quantization of gravitational fields may become apparent, where the intense gravitational forces generate entanglement with the quantum world on a scale that is virtually impossible to ignore. This tantalizing prospect has inspired physicists to develop a wide range of potential candidates for a quantum theory of gravity or a quantum theory of the entire universe. Some of the leading contenders include the Wheeler-DeWitt equation, named after the physicist John Wheeler. This equation attempts to describe the quantum behavior of the entire universe from the Big Bang onward, while still respecting the geometric nature of space and time as described by general relativity. This equation allows the universe to behave as a quantum system at the Planck scale. Loop quantum gravity. This approach treats spacetime itself as being quantized or fuzzy at the smallest scales rather than infinitely subdividable. It postulates that below the Planck scale, space itself exhibits quantized loop-like behavior, with quantum gravity becoming the overriding force. String theory. In this paradigm, all particles and forces are described as different vibrating modes of one common string-like structure in a higher dimensional space. String theory attempts to derive all the particles and forces of nature from a single quantum model. While all these approaches still face significant theoretical hurdles and have yet to be experimentally tested, they represent the most promising attempts to date to resolve the quantum versus classical divides and unify all the fundamental forces, including gravity itself, into a single overarching theory capable of explaining the origin of our entire universe. As daunting a challenge as developing a single unifying theory may seem, the vigorous research in this field is fueling rapid progress. With each new theoretical insight or experimental result linking quantum behavior to cosmological scales, we come one step closer to developing a paradigm-shifting new physics, one which could potentially unveil the ultimate keys to unraveling our universe's deepest mysteries. Developing the metaphysics mind, consciousness, and creation explored. Despite the significant challenges inherent in developing a new paradigm quantum physics framework as outlined above that successfully describes macro-level phenomena, it is widely recognized that a fundamental mind shift is also required to reconcile the apparent contradictions between our current classical physics worldview that treats things like fields, forces, particles, etc. as quantized, i.e. discrete objects. The traditional Eastern metaphysical perspective, which insists existence is fundamentally continuous and ever-evolving in nature. This apparent clash between mathematical mechanics and metaphysical perception represents a more fundamental point of confusion with the way we conceptually model phenomena. The approach science has typically taken to overcome these apparent contradictions is to analyze things from a detached, mathematical modeling point of view, e.g., it has had to apply quantized rules like operators/wave functions/probabilities, etc. to observables like position, momentum, energy, etc. to properly model their behavior at a quantum level. However, over the last few decades, we've been increasingly forced to adopt a still more detached systems perspective to think about entire systems rather than just individual observables or elements. This shift to thinking about entire systems as fundamental to a given domain has extended even to our modeling of very abstract phenomena like intelligence. This gradual paradigm shift is allowing us to explore a whole new family of deeper questions like, what defines intelligence and consciousness itself? How do we identify intelligence in complex systems? What minimal criteria must an entity meet to be considered conscious? These are the types of deep questions that are proving key to finally developing a theory of intelligence that might be able to convincingly map human psychological concepts from a pure math basis, to finally develop an overarching framework that could then let us think intelligibly about big metaphysical questions like, what is the fundamental nature of reality? What is the meaning behind apparent? How did the known universe come into existence in the first place? As cutting-edge new sciences like machine learning and quantum computing mature further, they could well yield new paradigms aimed at mapping the fabric of consciousness itself, uncovering the actual molecular structures and dynamics involved in natural intelligence as we explore and aim to reverse engineer it. Just as they revolutionized life sciences through techniques like gene sequencing and bioinformatics, machine learning and quantum engineering may be heading towards a true theory of consciousness, distilling down key components of intelligence to their finest essences, helping us finally get to the bottom of these deepest of deep questions. And building up from these more elemental structures, we could then bootstrap our way towards more abstract descriptions and intuitions on related advanced metaphysics, understanding intelligence and consciousness at progressively deeper levels, and how to map human experience and wisdom concepts. While the theoretical path ahead seems convoluted and fraught with difficulties, remember that while the macro effects of intelligence remain maddeningly mysterious to us, the molecular micro-building blocks are now coming into increasingly clear focus. As we continue developing our models and tools and techniques, our vantage points and comprehension of life's deeper complexities and intelligences should correspondingly advance, thus offering new paths and approaches to exploring and mastering the fundamentals of human intelligence and existence itself. Only by continuing to keep our minds wide open to the deep unknowns, the vast mysteries awaiting comprehension, can we hope to take our journey ever onwards. The human experience and time. While the philosophical debates and scientific theories surrounding the nature of time are intellectually fascinating, it is important to recognize the profound impact our understanding and perception of time can have on our lived experiences as human beings. How we conceptualize time, whether as a linear progression, a multidimensional landscape, or a subjective construct of the mind, can profoundly shape our sense of identity, our perceptions of freedom and determinism, and our ability to find meaning and purpose in the fleeting moments of our existence. Consider, for instance, the perspective of eternalism or the block universe, which posits that the entire timeline of existence already exists, frozen in a four-dimensional continuum. If we embrace this view, it raises challenging questions about the nature of free will and the extent to which our actions are truly self-determined. If the future is already written, do we have any real agency over the course of our lives, or are we merely following a predetermined script? Alternatively, if we adopt the view of presentism, which holds that only the present moment is truly real, it invites us to embrace a sense of presence and mindfulness, to fully inhabit and appreciate the fleeting instants that constitute the essence of our being. This perspective may offer a sense of freedom and agency, as the future remains unwritten, a canvas upon which we can paint the narratives of our lives. Yet, even within the confines of a single philosophical or scientific framework, our subjective experiences of time can vary dramatically. The psychological phenomenon known as time dilation, wherein our perception of time's passage is influenced by our emotional states and circumstances, reminds us that our experience of time is deeply intertwined with the workings of our minds and the complexities of our consciousness. As we continue to explore the nature of time, it becomes increasingly evident that our understanding of this enigmatic concept is inextricably linked to our understanding of consciousness itself, the subjective, first-person experience of existence that lies at the heart of our reality, the limits of knowledge and the pursuit of understanding. As we stand at the precipice of this profound mystery, one truth becomes abundantly clear: the boundaries of our knowledge are finite, and the ultimate nature of time and existence may forever elude our grasp. This realization, far from being a cause for despair, is a humbling reminder of the vastness and profundity of the cosmos we inhabit, and the depth of the mysteries that await our exploration. Throughout human history, every great leap in our understanding has been accompanied by the realization that the horizons of knowledge stretch ever further, unveiling new realms of mystery and complexity. The more we learn, the more we come to appreciate the depth of our ignorance and the immensity of that which remains unknown. The limits of our knowledge are inherent in the very nature of our existence as finite beings. Our perceptions and cognitive faculties are fundamentally constrained, shaping and filtering our understanding of reality in ways that may forever obscure the true, unvarnished nature of existence. Philosophical perspectives like Kant's distinction between phenomena and noumena remind us that our experiences are but subjective representations of an underlying reality that may be forever beyond our comprehension. Quantum mechanics and relativity have challenged our most fundamental assumptions about the nature of space, time, and causality, revealing a universe that operates according to principles that defy our intuitive understanding. Even the most advanced scientific theories and mathematical models are ultimately approximations, representations of reality that capture particular aspects or domains while inevitably falling short of a complete and unified description of existence in its totality. Yet, it is this very limitlessness of knowledge that fuels the unquenchable thirst for understanding that has driven human inquiry throughout the ages. The realization that there are depths to reality that we have yet to plumb, mysteries that await our exploration, is a source of wonder and inspiration, a siren call that beckons us ever forward. In the face of the unfathomable complexities of existence, humility becomes a virtue, a recognition that our pursuit of understanding is an ongoing journey, one that demands an open mind, a willingness to question our assumptions, and a reverence for the profound mysteries that surround us. Embracing the limits of our knowledge does not diminish the value or significance of our quest for understanding. Rather, it imbues it with a sense of reverence and awe. It reminds us that the true nature of reality is a tapestry woven from countless threads, each contributing to the rich and intricate tapestry that is existence itself. As we stand at the precipice of this vast unknown, we are called upon to approach the mysteries of reality with a spirit of curiosity, wonder, and humility. For it is in the pursuit of understanding, in the tireless exploration of the boundaries of knowledge, that we find meaning and purpose, and perhaps catch fleeting glimpses of the true nature of existence itself. As we conclude our exploration of the enigma of time, we are left with more questions than answers, more mysteries than certainties. But it is in this state of perpetual inquiry, this unquenchable thirst for understanding, that the true essence of our existence resides. We have journeyed through the realms of philosophy, pondering the nuances of presentism, eternalism, and the block universe, each offering a unique lens through which to contemplate the nature of time and its relationship to the fabric of reality. We have delved into the scientific perspectives, grappling with the arrow of time, the tantalizing possibilities of time travel, and the quest for a unified theory that could reconcile the seemingly irreconcilable, the quantum and the cosmic, the micro and the macro. Throughout this odyssey, we have been reminded time and again that our understanding of the universe is inextricably intertwined with our understanding of consciousness itself, the subjective experience of existence that lies at the heart of our reality. As we stand at the intersection of these diverse perspectives, we are humbled by the realization that the true nature of time, and indeed the true nature of existence itself, may forever elude our grasp. Yet, it is in this very pursuit of understanding, this tireless exploration of the boundaries of knowledge, that we find meaning and purpose. So, let us continue to question, to theorize, and to probe the depths of existence, ever seeking to unravel the profound mysteries that lie at the heart of time itself. For it is in the journey, in the act of seeking understanding, that we come to appreciate the profundity and wonder of the cosmos we inhabit. Until we meet again, cosmic explorers, may the mysteries of time continue to captivate and inspire you, and may your journey of discovery never end.